For this video today, we want to introduce the principles of a slide wire potentiometer. So what is a potentiometer? Essentially, it is a device to measure potential differences. So, how does a potentiometer work? As the potentiometer is often a challenging topic for many students, we'll spend a little bit more time today developing this idea. We'll first start off with what we have just learned, the potentiodivider. Then, we'll use this idea to talk about when a slide wire potentiometer can be used as a voltmeter. Finally, we'll come back and consolidate on the principles of a slide wire potentiometer. Before we look at how the potentiometer works, let us now look at this question. Given a cell of 16 volts with negligible internal resistance, can you find the potential difference across XY? To do that, we should always first draw the circuit diagram of this circuit. So we have a 16 volt cell in series with a 5 ohm resistor and a 3 ohm resistor. To solve the question, we first put in the currents. We note that the potential difference across AC is the same as the potential difference across XY. We also note that there is actually a same current that is flowing through both resistors. With that, we can write that the potential difference across AC, which is the potential difference across XY, as 5I. Similarly, we see that the PD across R2 is 3I. Since the same current I flows through both the resistor, we see that 16 volts is divided out between the two resistors in the ratio of 5:3, which is the ratio of R1 to R2. This is our familiar potentiodivider principle. And V1 should be 10 volts and V2 should be 6 volts. Let us now replace the two fixed resistors with two variable resistors such that the sum of R1 to R2 is always 8 ohms. Can you fill in the table given? Pause the video and fill in the table. When ready, play the video again to check your answers. As usual, before we solve the question, we should first transform the diagram to an easily solvable one. Next, we will put in our currents. Note that the same current passes through R1 and R2. Hence, we can use our potentiodivider principle to solve the question. For the first row, the ratio of R1 to R2 is 7. Hence, the ratio of VXY to VCB should also be 1:7. The total potential difference is 16, so we have 2 and 14. Using the same principle, we can fill in the rest of the table. We note in the previous exercise that the ratio of VXY to VCB can be determined from the ratio of R1 to R2 when the same current passes through them. Practically, however, when we are doing this experiment, this will mean that we would need to determine R1 and R2 separately using an ohm meter. This will be very tedious. Is there another way to vary this arrangement? Instead of using two resistors, we can replace them with a single wire of 8 ohms. Since R equals to rho L over A, if the cross-section of the wire is constant, then the resistance is proportional to the length. Hence, R1 is to R2 is equals to L1 is to L2. If we further have the same current through the whole length of the wire, using V equals to IR, we see that the potential difference across a length of wire L is also proportional to L. Hence, VXY is to VCB is equals to LAC is to LCB. This circuit that we have down here is known as the potentiometer circuit.